Okay, hello class, how are you? So today we're going to look at the nomenclature of alkanes. So nomenclature, simple terms, we mean the naming of alkanes. Nomenclature means naming. Nomenclature means naming. So when we name these hydrocarbons on the family of alkanes, first of all, we should also know the first 10 elements. And the first 10 elements goes like this one. That is methane, ethane, propane. So there's a general formula. I call it my education, prospered, Bart, Peter, Helen, helped, ate, on, no delay. So not delaying, this is the main formula that you can use it to master the first 10 elements of hydrocarbons. So the first element is methane, ethane, propane, butane, pentane, hexane, heptane, octane, and finally decay. So whenever you use the word my education prospered, but Peter, Helen, helped on no delay. So my stands for methane, education, ethane, prospered, propane, but butane, Peter, pentane, Helen, hexane, and so on up to decay. So that's how we should master the first 10 elements first of all before we go on to alkanes nomenclature. So we all know that I said that hydrocarbons in my previous class. We see that hydrocarbons, these are a group of elements that are compounds which are made up of carbon and hydrogen only as the only elements. Therefore, we need to look at this thing. We call it homologous series. Homologous series, in simple terms, we mean these are compounds that show similar chemical properties. They also they conform to a general formula, but exhibit differences or gradual change in their physical properties. So this one, it is the same as the chemical families we learned in chemistry book 2. It's the same, but this one we are referring to hydrocarbons. So they have similar chemical properties. That's the key one. They have similar chemical properties. They also conform to the same general formula, but they exhibit gradual change in their physical properties. So that is the differences between. In case you ask to define what is homologous series, then the name goes by that. Then besides that, we should also know now how do we name? That is, how do we name these alkanes? So the naming of alkanes, the names are these ones, but there's something we call isomerism. Isomerism of alkanes. Alkanes. So an isomerism of alkanes, isomerism comes from the word isomer. Comes from the word isomer. Then you get the name isomerism. So isomerism is a process. While isomer, these are hydrocarbons with this, that conform or with the same molecular formula, but different structural formula. So all hydrocarbons with a similar molecular formula, but difference with the different structural formula, we call them isomers. So the process is called isomerism of alkanes. So under isomerism, we have substituent groups, because we have substituent groups. So the substituent groups, we have substituent group, and then we have the name. So for example, the first substituent group, I'm just giving you some examples. For example, this is methane. So methane is written like this one. Methane, that is carbon with one carbon with 4 hydrogen with the same hydrogen, because all alkanes conform to a general formula of CnH2n+2. Yes, CnH to N plus 2. So they conform to this formula. So if we have only one under the first one, one carbon, then we have four of this, because it is 2 times 1 plus 2, which is 4. So it's that one. So in the molecular formula for that one is H, then CH4. So whenever we write CH3, then we write that bond, then the name changes. So instead of being called methane, because a methane must have four hydrogen atoms. So in case we have 3, then the name changes. We call it methyl. We call it methyl. So in case we have CH3, CH2, then another one. So this one, it should be ethane. It should be ethane because it has two carbon atoms, but the number of hydrogen atoms from this general formula, there must be 6. But since we have 5, then the name changes from ethane to ethyl. So the name changes to ethyl. The name changes to ethyl, and so on and so forth. Now, but the point is, and all the rest goes on like that. So whenever we have propane with the less number of hydrogen atoms, the less one, then the name the substrate group, the name of the group becomes propyl. That is it, and so on and so forth. So, for example, let me just give you an example here. Then you see how we name using those substrate groups there. Those substrate groups. Let me just give you two more. Maybe you know that in Form 2 we learned about the example, the halogens. So the halogens, example of halogens is just the chlorine, and another one we have the bromine, and then we have maybe iodine. So whenever we see these things attached to any chain of hydrocarbon, then for the side of chlorine, then this becomes chloro. We write chloro before the parent name, and then we have bromine, it should have bromo, and then we move on. Iodine, we have iodo, then we proceed on like that. So let me just give you an example so that you can understand it best. So example, just look at this one. We have CH3, let me just use the structural formula. We'll use the structural C, then that one, then let me just have bromine here, then C, H, and this is H. Then you ask it to give the name. So first of all, we should count the number of we should identify the longest continuous carbon chain so that can give us the parent name. So when you start from this side, 1, 2, there are 2 carbon atoms. When you start from this end, 1, 2, also 2. So it means that whenever you start from whichever side, then the number of carbon atoms remains to be 2. So the parent name is from the first 10 and from the first 10. This is ethane. But now we need to see, we have a substituent group here which is bromine, and we have written here bromine where we use the term boron. So since bromine is a substituent group, we start from the end where we can reach the substituent group with ease. So from here, then this one, from this end, this carbon number 1, this carbon number 2. So means bromine is attached to carbon number 1. If we start from this side, this is 1, this is 2. So from this end, this one is attached to carbon number 2. So 2 and 1, between 1 and 2, then 2 is larger than that one. So we go by the smallest, which is 1. So it should begin from this side. So this side, that is 1, carbon is attached to carbon. Bromine is attached to carbon number 1. So we shall have the name for this one, or we call it EUPAC, and the EUPAC name. The EUPAC name will be so the substrate group which is bromine, so we have is attached to carbon number 1. So we have 1, then bromo, then the parent name. The parent name is what? The parent name is ethane. Bromoethane. And that is the EUPAC name for this one. EUPAC name for that. Let me give you a second example. second example. So the second example, we just look at this one. Whenever you're given C, that one. From us. So first of all, we have to identify the longest continuous carbon chain. Longest continuous carbon chain. So we shall have 1, 2, 3, 4, 5. 5. Oh, 5. So 5. So the parent name from the first 10, then this is pentane. This is obvious pentane. 1, 2, 3, 4, 5. That is pentane. So the parent name is pentane. Parent name is pentane. So if the parent name is pentane, then we need now to look how many substituent groups are attached to the main chain. So we have chlorine and water and bromine. Okay. So under chlorine and bromine alphabetically, which one comes first? Obvious. B comes first before C. So we need to check which side, when we begin from, we get the lowest numbers possible. So when we begin from this side, the first one, which is bromine, is attached to carbon number 2. 1, 2. Then chlorine, carbon number 3. When we start from this side, the bromine is attached to carbon number 1, 2, 3, 4. Carbon number 4, while chlorine is attached to carbon number 3. So look at this. Whenever we add 2 plus 3, the answer is 5. And 4 plus this one, the answer is 7. So we go by the lowest. So the lowest is 2. So we start from this side. 2, and then this one is attached to carbon number 3. So the parent name is 2, 3, then comma 3. We shall have, so they are different. That's why you cannot combine them. So the first one is bromine. So we shall have 2 bromo, and then 3 chloro, then the parent name, which is pentane. And that is the UPAC name for that. Let me give you a final example. Because my time is very much going. So let me just give you the same example there. Maybe with substitute like that, and maybe another one. And let me just use iodine. Yes, that is it. So by looking at it, we have to consider to identify the longest continuous carbon chain. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. So the longest continuous one is the one with 1, 2, 3, 4, 5. 5 carbon atoms. So if there are 5, then the parent name is pentane. Pentane is the parent name. So how many substituent groups do we see here? We have 1. We have methyl, the methyl group, and then iodine, substituent groups. So between the methyl and the iodine, which one comes first? I. The I and the M. Which one comes first? So the one which comes first is the I. Yeah. So the I comes first. So if I comes first, then we begin from iodine. So beginning from iodine. So if we begin from iodine, we shall have iodine is number 1, while the 2 methyl groups each are in number 2. So whenever we begin from this end, 1, 2, 3, 4, 5. So iodine is number 5, while the 2 are number 1, 2, 3, 4, number 4 each. 4 and 4. So whenever we add the 2, then this one we shall get 5, while this is 8 plus 3 plus 5, we shall have 13. So 13 is larger, so we go by the lowest. So apparently, so an iodine, that is 1. So we have 1 iodo. Then we have, these are methyl groups. Then 2, 2. Then dimethyl. Then the parent name, which is pentane. 10. So the reason as to why we are using the word di here, because that di means 2. If there could be 3, it could be tri. If there could be 4, it could be tetra. Tetra. So that is it. So 1 iodo 2 dimethyl pentane. Dimethyl 1 iodo 2 dimethyl pentane. So that's the end of our lesson. So know how to write hydrocarbons and the possible EU alkanes. Thank you. Let's meet in the next lesson.